Hey everyone, Steve here with QRC. I wanted to show you a new application prototyping has been working on called WBT Analyst. So Analyst is a program that allows you to load up QVRT files and basically start to analyze them, both in time and frequency. So we're going to load up a 69-second file centered at 151 megahertz. I believe we're taking a look at 5 megahertz worth of bandwidth here. So this is just some frequency shifted FM radio I'm taking a look at right now. So as you can see, we've got the standard FFT display on top, waterfall display on bottom. What's nice is you can click and kind of pan around, zooming in and out of the data to take a close look at some of these waveforms. Now to this, we've also got a slider for the FFT resolution. So you could start taking a look at increasing resolution or increasing time resolution. So right now, this is showing 100 hertz per line, or we could move it up to 500, 1,000, 2,500, I think up to 25,000 hertz per line. So with this level of detail, we're actually starting to take a look at the individual modulations going on inside the waveform. Now, in order to achieve this, Analyst is actually using overlapped FFTs. And there's only so much data inside the file. So if we hit the point of where we're overlapping both in time and frequency, we actually do end up with weird smearing or Mourier patterns. So there's definitely a sweet spot in here that allows you to kind of visualize these things at the maximum native resolution inside the file. Let's see. So some of the features that we have in here, we have an auto range feature for the waterfall. It will automatically pick the high and low points and try to color and scale the graphs here accordingly. Let's see, we can change the waterfall theme. Grayscale or hot is usually what I tend to stick on. So let's put it back on hot. All right. So we're just taking a look at some FM broadcasts right now. Let's see what else we can do. Let's take a look at another file. We're going to take a look at some GSM data. So let's see what we've got. There's a good one. So when Analyst first loads up a file that it's never loaded before, what it does is actually it builds an index file, and that's how it's able to quickly load the file and index into the contents. Well, so when I pan around this file, it's actually generating all this FFT data in real time from the time series data. So now we're actually taking a look at a GSM downlink carrier. As you can see, it's got the characteristic patterns inside for GMSK modulation. So we also see little features like this down in here, and it's a repeating pattern that happens. I believe that is a synchronization channel. So if I bring it down to the bottom, you can actually see the spike here at the top. Okay. Oh, a couple other things. So when you move your mouse around, it's showing you the timestamp of where we are inside the file, which directly corresponds to a sample index. We also are showing the frequency inside the file as you moved left and right. What we can additionally do is instead of showing the FFT graph up in here, we can show a time series of the INQ data itself. So currently, it's just displaying the first 1,000 samples at that sample index. However, when we actually move to certain features here inside the file, you can see the pattern of the IQ data change. Also shown is the characteristic modulation type of the GMSK here, as seen inside the INQ. This is actually good for taking a look at short-featured bursts as well. So this was one of the first times that we actually got to see some of the data inside some of these DSMX pulses. So let's take a look. I think DSMX2 is a good file. Hold on, let's move to the top. All right, there we go. So right now, it's just static, static, static. I think I've got an extracted pulse in here. There it is. So it's automatically ranging. This lit up block is actually the short duration pulse of DSM-X2. So we're going to increase the resolution here on the time. So let's bring it down to the bottom. We're also going to increase the time. All right, so now we can actually see what's going on here with some of the data. And as I move across the threshold, you can actually see some of the characteristic spikes that the decoder would pick up on in order to demodulate this 64-bit block. We can take a look here in time, so you can additionally see what happens when I move across the boundary threshold. You can see the pulse, as well as some of the preamble going on, which follows into the rest of the data stream. All right, I think that's about enough for now. So talk to you guys later.